So you're welcome to our channel of Skills Learning Network for Excellence Knowledge. We are in experiment number 2 in physics practical. That is the continuation of our experiment physics practical. We performed the experiment number 1, source of errors. So if you are not ready for that experiment, subscribe our channel. You will see those videos. And it evolves with the chemistry practical, even biology practical. So experiment number 2, we are going to start our lesson, and by starting with experiment number 2, the coming lesson we are going to deal with how to derive the equation or the nature of the graph of your experiments. We are not dealing the solving in search by using the values or experimental results. We are going to consider the aim of experiment or the objective of experiments, and we will see, or I will show you how to derive, how to use the equation to know the nature of the graph and the other values which have been asked within experiment. We are going to consider the circuit of the experiment. So experiment number 2 is to determine the electromotive force of a battery and the internal resistance of the battery. You can be provided with a cell or battery. When you say battery, it means you have 2 cells, and if you have 1 cell, you can find the internal resistance and the electromotive force of the 1 cell. So we proceed with the experiment number 2. That is our aims, to determine the electromotive force or E.M.F and the R, which is internal resistance. And let's look at our circuit of diagram, experimental circuit. We have E.M.F, we have switch, we have resistor. Can be resistance box or can be standard resistor, but always we use this resistance box, and there is different. There is 100, 0 up to 100, there is 0 up to 10, and the more it depends the quantity of that resistance box. And we have ammeter to record the current. So our table that will evolve the resistance and the current flowing through the circuit. That is our circuit, and you have to know how to drive according to that you have been provided apparatus. The questions after performing experiment, always the experiment it has procedure, but by considering that circuit, you can know how to record the experiment. The procedure is the description of the circuit. So the questions for that experiment: plot a graph of R against 1 over I, that is resistance against the reciprocal of current. Question number 2, calculate the slope of the graph. Number 3, what is the physical meaning of the slope? And another question, deduce. This deduce, you can say that is calculate or find the value of E.M.F and the internal resistance of the battery. So apart from that questions, I will show you how to calculate, how to suggest how you are going to find the value of E.M.F and the internal resistance of the cell. And we will see the physical meaning of the slope by looking the nature of the graph, the theory through equation. Let's proceed. The theory of the experiment. General equation for this circuit: we have E.M.F, we have resistance, we have current. Our general equation is this one: E.M.F is equal to current and bracket resistance plus internal resistance of the battery or of the cell. Our graph we are supposed to show by making correlation with the linear equation. So the graph of R against the reciprocal of current, that is our general equation. So from this equation you have to derive, to arrange. It means R is y-axis and the reciprocal of current is x-axis. Let's we proceed with that derivation. EMF is equal to that one, I bracket R plus R. In order to get R, which is the subject, you have to divide EMF of current is equal to R plus R. EMF of current minus R is equal to R, that is the subject, and our equation is R is equal to E over I, or current, minus R. So in order to get the axis of X, 1 over current, the equation is this one, and the linear equation is Y is equal to mx. That is the nature of the graph. So that is the equation which represents the nature of the graph. This is y-intercept. It shows R and R. Y-intercept is negative. Do you see that is the nature of the graph? And your graph should be, when you are going to plot by using the scale, by using the value of experimental results, you have to show your graph is going to cut in that y negative axis. Then when you look, our slope is EMF. M is equal to slope, which is equal to EMF, and the x-axis is equal to 1 over I. C is equal to y-intercept, which is equal to negative R. Therefore, how to calculate EMF? EMF, we have said that is the slope. So the slope is equal to change over R against the, or divided by change over reciprocal of current. So EMF, when you get the value of the slope, that is a value of EMF, and the SI unit is equal to volt or potential difference, and the y-intercept is equal to negative R, which R is the internal distance. So in order to get the internal distance, you are going to read the value from the graph. You are supposed to read the value of here, y-intercept, and then you are going to equate to the equation to make a substitution. It means negative C, which is negative, is equal to negative R, and the negative R will divide by negative, so R is equal to the value of y-intercept. So generally that is derivation, and to see how the graph can be solved and how to get the value have been asked within our questions. The value of EMF is equal to slope, internal distance is equal to y-intercept. Physical meaning of the slope is equal to electromotive force, and the slope is equal to EMF. The graph is cutting through the y negative intercept. I think that is the theory of the experiment for the second experiment, and the circuit is this one. I think you have understand. Thank you for learning with me. Subscribe our channel, share this knowledge. Welcome again to learn for the next experiment. Thank you for learning.